All right, welcome back. We're taking a look at very quick notes today. And we're going to look at matter. So probably a definition you've heard before and seen before. I'm not going to spend too much time on it. Matter is anything that has mass and takes up space. Now we can classify matter as generally two things. Substance, which we can further break down into elements, like oxygen. Now here's the trick to oxygen, all the same type of atom. Oxygen, O2, elemental oxygen, is two oxygens together. There we see it, there's two of them. So it doesn't just mean one atom. You can have thousands of atoms, millions of atoms, billions of atoms, as long as they're all the same type of atom. For example, all oxygen or all carbon, if you look at the tip of your pencil, the graphite there is almost completely purely carbon. So this is elemental carbon. As long as you have all the same type of atom, same element of atom, it's called elemental. So there's our element, and that's opposed to the other type of substance that you can have is compounds. And compounds are potentially two different types of atoms. So two H's and one O. So always the same consistent ratio, two H's, one O. And as long as all you have and everything you have is two H's and one O, you have a compound, and that's a pure substance. As long as you have that substance, water, H2O, it's a substance, and that's how we classify it. On the other side, we can also have, so we have substances and we have mixtures. And mixtures can be one of two things. They can be homogeneous or homogeneous, depending on how you prefer to say it. And that's when you have an equal mixture. So see how our mixture is kind of evenly mixed here. It's not, I didn't do a great job, but we've got equal numbers of the big circles and the little dots. Doesn't mean the same number. So I've only got 5 of the big circles and a lot more than 5 little dots, but they're evenly spread throughout. Or they can be heterogeneous. So an example of homogeneous might be like salt water. Or as an example of a heterogeneous, and here we can see we've got all the little dot particles on top and the different particles, which in this case would be squares, they're on the bottom. So they've separated out. So heterogeneous mixtures or heterogeneous mixtures, however you want to say it, doesn't matter. They are not evenly mixed. They usually settle out. And this would be like sand and water. So the sand particles would fall to the bottom, and the water molecules would stay up top. All right, 2 last things to add to this real quick, just 2 kind of definitions here. Homogeneous mixtures are called solutions. We'll work with that a lot more next semester, but just a term to be aware of. Homogeneous mixtures are called solutions, and both of these are molecules, which is specific to covalent bonds, which is all we're working with this chapter. So these guys are both molecules. So they're compounds that are bonded covalently. This one's a solution. It's a homogeneous mixture. Just a couple of key terms there, molecules and solutions that go along with all this. And there we go. Like I said, pretty quick notes today. So I'll see you next time for our next lesson.